I would like to talk a little bit what we at Transform, how we are using Docker, how we started using Docker. As I said earlier, the meetup was kind of found in the premises that question why who is using Docker in production. I'm not going to give you that. The reason is because Transform doesn't have a production system. So just a quick, what does Transform do? I mean, we're not a name like Red Hat or Spotify that everybody knows what the core business is. Transform, what we do is we build network equipment for fiber optic networks. So our customers are basically telecom operators. Why do we use Docker? Basically, what we sell is this. Embedded systems. But then we also do a whole bunch of what we call network management. That's basically application somewhere in a data center to manage all that in a software way. And that's where I and my colleagues are sitting among you work with network management. So we develop large-scale Java applications for different features. We don't have a production system because what we do, we develop software and we ship it to our customer, the operators, and they deploy it in their own environment. So what we have is we have our test environments, which can be quite large and extensive. We simulate large optical networks with thousands of sites, and we have large servers to kind of test those networks. But we don't have a production system as Spotify has, for instance, or other large companies. So what we got in contact with, the reason why I got hooked on Docker was basically we were thinking about how should we manage our test environment, which has lately grown up to several dozens or almost 100 virtual machines that we try to keep up to date and synchronized, but it really doesn't work because it's not a production system, so we don't have any routines about it. So the idea arose that we want to use something called immutable servers, or kind of one-shot servers, as Emil was talking about. We don't have to care what the configuration of the servers are, we just start a new instance once we want to start testing something new. And that's where Docker really shines. In the group I work, what we develop is Java applications, and our tool chain is quite simple. Well, considering that we're using Java, we use Gradle as a build system, and we have Jenkins as a continuous integration server, and we would like to add Docker to the mix. What's nice with Gradle is that, I don't know, anybody know Gradle, or anybody not know Gradle? Right. The Gradle is basically a build system for Java. It's a DSL written in Ruby. It's a very expressive build system that still has the strength of maybe the descriptiveness of Maven, but the flexibility of Ant. So you can basically encapsulate all your build logic within Gradle without having to resort to bash scripts or Python scripts on site. So our build pipeline. So I'm going to talk a little bit more from the developer side. We are developers. We don't have. If we talk DevOps, we do development. We don't really do much operations. So what we have is our build pipeline, where we build our software continuously, we test it, and so on. And the last stage, we have a full packaging. And installation what we ship to our customers. And that's basically a fat installer that they install in their Red Hat system or Solaris systems. We don't have any control over their deployment systems, so we really have to ensure that that installer kind of does what it's supposed to do, and we have to assume that their system is in a second state. And that's where I would like to add Docker deployments to start with internally. So, what I've been working with is to integrate Docker creation of Docker images that Emil quickly brushed from Gradle. quick background. So he showed you a quick Docker file. Another example. It's actually almost the same. I think it's almost the same example. It's also Nginx. That's just an example I pulled from Docker's documentation. The point with Docker files is that you basically you specify what you want the image to be, and then you just Docker build it. And after every step, so after every line, Docker will snapshot the image for you. So it's actually very fast to incrementally build on a Docker file and keep on building. So what we basically would like to do is what we need. First, we have this base image. Here is Ubuntu in that example. What we need in our example, we developed Java Standard Edition application, so no application server. So we basically need an operating system with a Java virtual machine. And then what we like to do is we just add everything that we built from Gradle into the virtual machine, into the container and run it. So what we could basically do and what we start with is we add the Ubuntu image, we install JDK with apt-get in the Docker file, and then we add all the jar files and start scripts into the container, and we start it. That works, but it's not really something that you want to do automatically. And not something you want to maintain. So back to Gradle. What we do in Gradle, there's two plugins that we extensively use. One's called the Java plugin. Gradle is not only for Java, but that's what we use it for. And there's an application plugin. So if you have a Gradle file and you just use the plugin application, it will create a whole bunch of start scripts for you. So you can easily bootstrap a JVM, Java Virtual Machine, and it for instance adds a task, so you can easily distribute your Java application as a zip file or a tar file, and it also adds a task to install your application on code. So what we did a plugin for Docker, which is called Docker. We did a plugin for Gradle, sorry, and it's called Docker. So what you basically do instead of those two lines, you write that. So if you just have application plugin, you get a task that's called dist-tar, which makes a distribution, tarball of the distribution. And now when you add the Docker plugin, you get a task that's called dist-docker. And what it will do, it will build a Docker container with your Java application and push it in your repository, or register actually. So let me show you. Before I'm going to show you, I created kind of an example that's, I want to first start out with a real world example, but the thing is, if you try to find a real world Java Standard Edition example that's kind of a server application that also uses Gradle and is really easy to get going, and you kind of like, you can easily see what you're doing, it's not that simple. So what I did is, I took an example from Jetty. Jetty is an embedded Java web server, and just made a really simple main method that starts a web server and serves something simple. And that's my Java application. And then what I did, so what I'm going to do now, let me first show the code. That's my Java, that's my main method. Dark. The thing is, what I'm going to do is I'm going to change it. It's basically, that's a really simple and the main method. It's just directly from the tutorials. I'm going to just change that line and I'll have a Docker to something else. I will commit it, push it to my Git repo, have Jenkins pick it up, build it, and push the new container into the registry, which we also have locally. And then I will go to my Docker host, pull the new container and deploy it. And hopefully that will work. We'll see. There's quite a lot of moving parts, so we'll see if it works. But let's take it step by step. So let's just check. Let's just change that to Hello DevOps. Commit it. Okay, I pushed it. Let's go to Jenkins. Here we have now that one. It's not a push trigger, so it's just checking checking the rep every minute. So it should pick up the change when it's soon, and then we'll start building it. It will show up here once I start building. Now it starts building. That's not the hard part yet. But what it basically does now, it's going to execute Gradle this Docker, which is it just uses Gradle and the abstraction hand is within the plugin. So it seems to be that my network is a little bit slow, but Jenkins is now it's not on my machine, it's somewhere in our development system. It's pulling the new code, it's going to build it, and it's going to push the new image to a registry. Okay, and just quickly here, console output. So it just basically does a Gradle tasks. So here it's executing this Docker. What it does, it creates a Docker file for my Java application and builds it exactly the same way as Emil was doing manually with Docker build whatever. After that, it will tag it, so it gives it a name basically. That means so you don't only have that SHA-1 like look kind of ID. And after it has done that, here it built it, and then it pushed it onto our registry. So I think there was a question somewhere there, how we deploy Docker. So you can push containers up to the Docker index. That's public, or you can push it to your own repo somewhere. It's a simple Python application just to start on a server somewhere, and you can push to it. And yeah, the output is not really that pretty, but what we see is it at least was successful. So hopefully we got a new container now. Now here I'm on my Docker host. It's a virtual machine in our test environment. And I'm going to pull the change now because I have to tell it to update my image. So I basically Docker pull, and then the name of the image. And then how Docker handles local registries, it's just if you have a name that has a host name and a port as part of their tag name, it assumes that you do it locally. So instead of having a username and then slash the container name, as you would do an index, as I think both of you showed, you use a host name and port. And the container is called Docker Chetty, and then latest means just the version. So I'm going to pull it. Pulling something. I think it's done. It's a little bit output is not that pretty on that small screen. No, okay, it's done. So now I'm gonna, if I do a Docker images, you see a whole bunch of images. That's not really that pretty either. But up here we should see the latest one. It was that's the one we just built. And it was created 2 minutes ago. So that sounds promising. Let's run it though. So I just run it, -d, as Emil showed us, just demonize it. We run that image. Let's tell everything we do. Let's check Docker PS, show us the containers that are up and running. And here's the one that we just started up 3 seconds ago. And it's binding on port 49156. The Chetty web server is exposing port 8080. So let's check that port. What did I say? Here we are. thing I'd like to point out, as you see here, the Docker PS shows you the processes or the containers that are running. We actually have 4 going and running on different ports and have them open in different tabs, such as previous versions. But they're still running. They just have their own isolated file system. Just all the versions of the same software. And they don't disturb each other. What the plugin does in its own, if you just use the plugin without, you can just use the plugin in Gradle without application plugin, and then you just get a possibility to create Docker files within Gradle. Looks quite similar to actually writing Docker files, but instead of using Docker ESL, you get instead of an add command, you get add files, and you can use Docker's way of describing files. You tell it with flags if you push it or not. You can just do a dry run to create a Docker file for you instead of actually running Docker. Because usually in our development environment, we don't have Docker installed because of what Alex was talking about before. We don't use Ubuntu in-house. So you might want to just create a Docker file for testing purposes and then actually deploy it somewhere else or build it somewhere else. So the whole bunch of flags. The plugin is very new. The latest version was just checked in today. So, and unfortunately it's not open source yet, or not, it's not released yet, let's say that way. So hopefully in the end of the week it will be released. And you will find it on GitHub, on our company portal. Right now it only works for Java applications, but basically Gradle is, you can use Gradle for different kind of platforms and languages. We don't really have the knowledge to use it to deploy different applications, but I'm sure it's possible because the application plugin in Gradle is actually agnostic of languages. What it also does, for instance, it reuses a whole bunch of information it gets from your Gradle build file. I don't know if I have an example of a Gradle file. So, I could show you that. That's the Gradle file for our project. So here you say, we have a Java, it's a Java project, up there. It's an application, we want to use a plugin application I spoke about, and of course the Docker plugin. And then we tell it we want to use Java 7. And that also, that information is used by the plugin to actually pull a base image that has Java 7 installed. If you write 1.6, it's going to use a runtime that uses Java 6. And it uses your version tags and everything like that to tag your container accordingly. The main class name, for instance, that's then used to build the start scripts. And then what you can then, if you just do everything by default, it will work. But maybe you want to tell Gradle which kind of or Docker which kind of port you want to export. In our case, 8080. So I do that explicitly here. We define our registry. If you don't, it will use the index. And then you can tell it to push it. Right now, it means if you don't tell push through, it's going to not push it for you. It's just going to build the container and you can push it manually. Yeah, that's basically what I wanted to show. It's kind of more of a prototype concept, but I think internally we can at least use it for deployment of test environments. To the test environment of our Java applications. And maybe somebody will find use for that as well. Questions?
Are Docker images signed?
No, I don't think so.
They're not. They're tarball.
You can export it as a tarball and you can sign that. But on the registry it doesn't have any support for signing anything.
Well, there are works in they're talking about verifying authenticity of images, and signing is part of that. I did not follow in detail. They're working on some way you can enhance trust in a particular image. Like this was actually created by this guy. But I don't know the details.
Another question?
Yeah. So what if I am stuck in Maven land? Is there any hope for me?
Maven doesn't make it easily for Maven. Okay. No, I don't know. I don't know Maven much. So to either.
I don't want to either, but
No, but I mean everything the Docker plugin does, you can do easily by hand or with scripts. It's not any magic. It's just we use the same kind of DSL as Gradle does, so to simplify the whole process and hide a whole bunch of, abstract away a whole bunch of stuff. Yes.
So how do you define mapping from, say, demo version to base image?
Right now, you can actually Gradle also has a way of extension properties, so you can actually define 1.7 is that image. So if you have your own images on your registry, you can define you want to use that image. For instance, a Red Hat image with an OpenJDK. I just picked something on the index right now, just for testing purposes. But you can, it's
You can override it.
Yeah. Because there is the index, as you said earlier, it's like a base image. The Ubuntu image is official. Everything else is just user contributed mostly. So if you look for Java 7, there's like 20 images, and you don't really know which one to trust. But just the one that's downloaded most is probably fine. So I mean, this is not something you want to do in production yet, but you can build it yourself and then tell Gradle to use that. And the nice thing is because actually Gradle, the plugin actually creates Docker files and creates kind of staging area for Docker. Because Docker build wants everything to be in one directory when it builds the container. You can easily debug it. You can run Docker yourself and see what does what it's supposed to. Okay, if there's no more questions, I would like to talk about your work at Spotify.